So on the code side, you have everything in your IDE, right? And you can do a lot of dependency analysis, lot of that kind of stuff in the IDE itself, right? Like you want to rename, you can use the Martin Fowler's rename, refactoring very easily. Like in IntelliJ, Shift F6 will rename things. It will go ahead and rename everything else and that kind of stuff. Pretty straightforward, right? And the reason for that is code can be dynamically analyzed by the IDE and it doesn't carry any state, right? Versus a database, you can probably rename a column, but you don't know all the interconnections. And you also do not know the interconnection between the database schema and the application because you cannot dynamically like do that linking. You could just have XML file somewhere that says that's a table name. And the IDE doesn't understand that the XML file doing the configuration of the table name is sitting over there. And that in turn is like talking to a database somewhere where the table name is this, right? So that disconnect creates a lot of fear.
Hey there, welcome to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toops. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, this is another special episode of Book Overflow. We were fortunate enough to interview yet another of the co-authors of Building Evolutionary Architectures, Pramod Sadalage. And we are adding to our ThoughtWorks representation on this podcast. We've had several of the brilliant consultants from ThoughtWorks here. Who is that so far? That's Neil Ford, Rebecca Parsons, Martin Fowler, and now adding Pramod. Really fantastic to talk to Pramod, especially his big focus on data and databases. Nathan, what can our listeners expect from this interview?
Yeah, it was great. I mean, we get to elaborate on topics that were brought up from the book. So if you followed us in the book discussion as well, he got the opportunity to dive into large language models and how that's affecting data and just all the different ways to approach it. You know, data lags behind engineering practices for a lot of reasons, partially because they just don't even hang out in the same conferences as what he brought up. And yeah, it was really cool to see his focus and his contributions to the book through this interview.
Absolutely. I think data can sometimes be a neglected part of the architectures we build. We just get it done quick and dirty and make sure that all of our data persists, right? So to hear from one of the experts on data and how you structure your databases to make them both evolvable and easy to work with, really a pleasure. This is a veritable treasure trove of information about data. So please enjoy this interview. This is Pramod Sadalage as he reflects on building evolutionary architectures. Well, thanks so much for joining us, Pramod. How are you doing today?
I'm pretty good. Thank you, Carter and Nathan. I have heard a lot about you guys, so looking forward to this conversation.
Well, that's great. We've been looking forward to it too. We are fortunate to talk with Neil Ford and Rebecca Parsons, who also are co-authors on the book. And I guess we'll start off by giving you the same question we gave them, which is describe the computer science industry at the time where you wrote Building Evolutionary Architectures or co-authored Building Evolutionary Architectures, and describe to us what about the industry motivated you to sign on as a co-author.
Yeah, so maybe it's a much longer history than the actual date when the book's writing started. So like a bunch of us doing a lot of this agile work back in late 90s, there's always this question, the first time where you hit, we have not done this kind of stuff with agile, for example, right? So people, like, the first place where people started is, can I like refactor my code, do evolutionary design with code and that kind of stuff? And then, I have not done this before, so let's figure out how to do this. And slowly, like, you build on top of each other. Like after code comes like, how do I break down iterative story writing, evolutionary story writing, and that kind of stuff. And then the next thing comes in evolutionary database design and that kind of stuff, which I was very involved with. And then the ultimate, like, higher order things of architecture, like how can you build architectures that help you in evolving things, right? So I guess this long journey and evolving architectures is kind of like a cap on a bunch of other things that happened before that, right? So that's how we got there. And any kind of system doesn't operate in isolation. So back in the day, you could just build one system, like, okay, I'm done. Like, that's all my company needs. That's not true anymore. Like, you go to any company of any reasonable size, there are hundreds of things people are using, and the bigger the company, probably it ends up being thousands of things. And then within those thousands of things, how do we ensure either the one thing you're building or the n number of things that you're responsible for making sure they talk to each other and that kind of stuff? How do you build a thing that can evolve over a period of time? Like, that's a question that is very pertinent to, like, every conversation you'll have with anybody, like a tech lead and higher kind of a role in a company. So that's, I think, is the problem space we are trying to address and solve and that kind of stuff.
Your primary contribution to the book, if I'm understanding correctly, was about the work with databases and building kind of an evolutionary database structure. Is that correct?
Yes, that is correct. Yeah.
How did you come to become an expert in databases?
Okay. So back again, I want to go back to this history of like when I first joined at ThoughtWorks, the late 90s, we were not doing agile, right? Like we are like a non-agile, waterfallish kind of company. And Martin Fowler and Ward Cunningham, if you know who that person is, came in to like coach us on agile. Like, we were very, very excited about this whole concept of, I can take a thin slice of something and develop and put it in front of a user so that we can see it work and we'll have something deliverable instead of like analysis for 6 months. And then, if you remember back in the day, we did a bunch of analysis, then we did a bunch of like ER diagrams and a bunch of table design and that kind of stuff. And then we went into coding of the actual business logic and the UI. So we had like 600 plus tables designed in an ER model. We had like a big folder of use cases and all that kind of stuff designed and written and that kind of stuff. And then we were thinking like, oh my God, this is taking too long to get something in user's hand where they can actually get something to use, right? So that was one motivation. The other motivation was this excitement. Like, I remember Matt Famel and David Rice, a bunch of like developers on our team, were like, hey, this JUnit sounds pretty cool. Like, we should use it and that kind of stuff. So those two movements came together and said, oh, let's learn what this agile means. And then Martin and Watt Cunningham came into us with, they were teaching us, mentoring us, coaching us on what this agile means and how do you think about it and that kind of stuff. And out of that came iteration one, that we said, oh, let's make an iteration one out of this. And that 1 month long, that's what we had planned, first iteration. And then we said, okay, let's do this minimum functionality that needs to be done. The user can book something on the screen and I can persist it in the database. That's all I want to do, like the bare minimum, right? And then we said, fine, let's go do that. And after the iteration planning meeting, I went back to my desk. I remember I had 600 plus tables in the database already. I deleted all of them and said, okay, these are the only minimum things I'll need. And I'll get to them as and when the stories play out. Like, I need to do this. Okay, what does it need? And like the tables and that kind of stuff. And then iteration 2, iteration 3. And over a period of time, I realized the ways of working that were before this of the waterfall, like where I have all the tables in one place, is not going to work, because I'll have to come up with some kind of iterative management of this. Because as things are iterating, you are then changing the structure that was already existing of tables that you already had. Plus, you're adding new tables. Those new tables are connecting to existing tables. Names are changing. The concepts are changing. A bunch of those kinds of things are happening. And I cannot have, here's my master schema script kind of thing anymore, right? So stuff has to iterate. So that's where this whole like iterative idea of things came up. And we developed the first framework to apply iterative schema. Like, nowadays, you take like Ruby Migrate or Python, SQL Alchemy, and all these things for granted. At that time, we had nothing, right? So we came up with this first concept called DB deploy. That was a tool we wrote and open source later on. Is like iterative application, and that's where I was deep into these things. Then coaching other teams at ThoughtWorks, whichever clients we went to, coaching them to use this stuff. And over a period of times, I kind of got known in the industry as the evolutionary database expert. Like, I didn't actually set out to be that, but that's how it happened.
Just happened.
Yeah.
One thing I love about this industry is just how many little niches there are that you can focus on. And, it's like, and I guess how rewarded you'll be for becoming an expert in those areas. Like, you can think of someone like front-end development, which is kind of completely different from back-end development. Even back-end development is way too big a term to encompass kind of everything that goes on there. But you think about like front-end development. Well, you could be a front-end developer, but you would also be really richly rewarded for like really understanding like, how is React actually working? Like the React processing loop, right? And not just how do I make the thing appear on the page. And so I always like to tell people who are kind of starting out, like, that there's so much of this field you haven't discovered yet. What was it that drew you to databases in particular? Because I'll be honest, and I've talked about this on the podcast, like databases, like my eyes glaze over. Like I wish every database could just be a black box that I never had to think about, right? And so I have a lot of respect for people like you who understand it deeply. What drew you to that particular niche as opposed to other ones?
I would say, as all things in life, it was accidental. Because the first job I worked, we were working for a company that was trying to build some kind of a software development system. Think of like back in the late 90s, again, RAD systems were in vogue. Like you could have heard of like Power Builder or Gupta SQL or Magic Software. All of this were trying to, you can develop with anything, deploy against anything, right? So you could theoretically develop against, like, say, Btrieve, or you can develop against SQL Server. And if you wanted to, you can deploy for Oracle or Kix or whatever, like a transparent persistence layer. So I was in the team that was working on the transparent persistence layer. So I got like fascinated with the way you can store data, get retrieve data, and how like some concept, business concept that is represented in certain way manifests itself on the data side, right? So on the object side, we talk about like, oh, here's an object, customer object has a collection of this, that, whatever. And how does that manifest itself in the persistence layer, right? In those days, relational databases were a big thing. So we had like, oh, this thing can be translated as a table. This other thing that's a collection on this base object could be a joint table somewhere else. And this order n+1 queries was a big thing. So that's how this will all get translated, and how you design that to determine how the performance of these things were there. So I love this space of like translating databases for developers, right? Like I'm not a core database like guru who does like database maintenance, backups, and that kind of stuff. But I love to translate database concepts for developers so we can together come up with a better solution, right? And some things you can, like, for example, iterate in the code. And what if I iterated in the database and gave you something that is easier for you to work with? So that thinking, I think, is what I'm generally after. So use the database for what it is good for, and let the application use the code for what it is good for, right? And not try to do database work in the application or try to do application work in the database. Both ways.
I love it. That's something I've been trying to focus on in my career too.
Yeah, I loved the data parts that were in the book. So I've been in ML ops and machine learning and SRE work. So I ended up interacting a lot with the data teams over time. And I feel like, just like the book identified, there seems to be this lag in the industry where maybe we've adopted agile processes, but the data processes are these hidden couplings that kind of come in. And I just found myself like nodding my head the whole time. And I will tell you, it's already impacted the way what I thought was possible as far as like engaging with teams. We read the second edition of the book. Was data between the first and the second edition, was data more a section of the book as opposed to now where it's sort of there's a sort of a data section in many of the chapters?
Yeah, like I think the first edition was more like I was contributing little here and there, and then in second edition we kind of tried to extract all those things and put it in one flow so it's easier to read and that kind of stuff. But going back to this disconnect, right? Like lag that you mentioned, uh, that lag is what I'm trying to solve for 25 years. Is this lag of like practices and things and whatever, right? That people have follow on the dev side but don't follow on the data side. But at the same time, there are some tools and techniques on the data side that are not followed on the dev side, right? Things like that, right? Uh, and the street is both ways. And how do we make it happen, right? So that's a big focus has been of my life, of like making that easy for people to like understand and take the power of the tools that are available on both sides. Like a very simple example of this is like version control, continuous integration, continuous deployment, and evolutionary design for the data side. Like people don't version control as much, people don't test as much, like especially automated testing. People don't do like, hey, can I like check in something and go through a series of tests in a CI cycle? Everything passes. I want to deploy ready package on the data side. People don't do that much. There's a lot of fear, like, hey, what if I change this? And all these things that are connected to it can break. And that fear comes from the fact that I don't have, like in code, for example, like let me know if I'm going too much on a tangent, I can stop, because you can tell I'm excited about this topic. Yeah. So on the code side, you have everything in your IDE, right? And you can do a lot of dependency analysis, a lot of that kind of stuff in the IDE itself, right? Like you want to rename, you can use the Martin Fowler's rename, refactoring very easily. Like in IntelliJ, Shift F6 will rename things. It will go ahead and rename everything else and that kind of stuff. Pretty straightforward, right? And the reason for that is code can be dynamically analyzed by the IDE and it doesn't carry any state, right? Versus a database, you can probably rename a column, but you don't know all the interconnections. And you also do not know the interconnection between the database schema and the application, because you cannot dynamically like do that linking. You could just have XML file somewhere that says that's a table name, and the IDE doesn't understand that the XML file doing the configuration of the table name is sitting over there, and that in turn is like talking to a database somewhere where the table name is this, right? So that disconnect creates a lot of fear, and because of which people are afraid of following these practices. And one way to, like, we figured out back in the day and even now is like we should just have tests, like tests that go from the persistent layer all the way down. You modify something, run your test. If the test failed, you broke something, go fix it and run again. Like the same thing that a developer would do, like standard. Like I build something, I modify something, I run the test, and then if something break, I made some mistake, or probably I didn't understand something, go fix that and run the test again until it passes, right? So this is one layer where you could get better on the data side. The other layer is this dependencies that are not visible to me. In any enterprise, any database, of course, this is the database integration pattern that Gregor Hoppe was so against, and I am against too, is people go directly to the database instead of going via an API or things like that, right? So it happens, that's reality, like you can't undo that anymore. But when that happens, you should have good set of tests. That's what the fitness function, that's where that comes in. You write a fitness function that says, this is what I'm expecting from the database. If someone changes it, they should be notified that, hey, I'm dependent on that thing, you're modifying it. Then it's not that don't modify, it's just a point of like, okay, now let's collaborate what you want to change into and what am I expecting, can you still meet my requirements, and that kind of stuff. It's a starting point for a conversation, right? So those two things combined together would give you a lot of like this ways to modernize the way you work with data.
It's been a recurring theme on this podcast that fear is often a sign that you've done something wrong with the way you're structuring your code, right? I used to kind of think, well, if I'm scared to touch the code base, that's because it's a really big, impressive code base. And you can take that to your databases as well, right? Well, if I'm scared to touch it, that's because it's very valuable and it's very important. And isn't it good that we're building valuable and important things? But just after reading like Building Evolutionary Architectures, especially your sections on databases, Working Effectively with Legacy Code by Michael Feathers was a big influence
Yeah.
there. Refactoring by Martin Fowler, which all kind of lays the foundation for here are ways you can reason about these systems. Here are ways you can make changes safely. What do you think it is that, why is the database side kind of lagging behind everything else? It's just like you said, like we're all on board with automated testing and version control and things like that for our code. Why is the database lagging behind?
Yeah, I would say maybe two or three things. One is the classic thing that Jess Humble used to mention, that developers are paid handsomely for creating a lot of change, like the more features you bring in and that kind of stuff. But the offside people are paid for stability, right? And any new change is a risk for stability. And that's why people say, hey, no change kind of stuff. That's probably a big factor in avoiding or getting to this state where I want to analyze everything, I want to slow everything down. I don't want to automate. I don't want automated tools deploying stuff and that kind of stuff. The other bit here is the tooling. Like nowadays, we have lots of open source tools and developers actually providing tools that help you do that. But tooling is a big deal, especially like think of like linting tools, think of like complexity tools, think of like all these tools are available on the code side. Why can't I have that easily integrated for database side also, right? So there are certainly some linting tools available nowadays. There are some like dependency analysis kind of tools, but most of the tool vendors, like database vendors, if you look at their dependency analysis, it generally, hey, right click on the table and it will show you dependency. That's not helpful for me in a code pipeline, right? They could theoretically come up with like tools that support pipeline development. In the pipeline, I can run something on a command line and figure out dependency. Or I could like create a plugin for IntelliJ that can give you dependencies very. So there's a lack of tooling that is also creating this issues. And the third is like, again, in a database, there are two things. One is state and the second is code, right? So people think of, I got like a backup of my database. Like I take a daily backup, I take snapshots. Okay, I got versions. Like what are you talking about version control? But when developers say version control, they're talking about the version control of the code, not necessarily of the state of the data, right? So there's a little bit of impedance mismatch happening there. And I think people are getting better at that, like especially like schema control or schema version control, as well as like code version control, like are all my stored procs in version control? Like a pretty simple statement. If the answer is no, then you should have that under version control. I see those as three big main reasons for stuff being. Maybe a fourth reason I used to think about this before was we are like the data set people and the application set people are attending totally different conferences. Like you try to pitch like a database design or a better database DevOps practices talk at like a front end conferences. Nobody's going to accept it, right? Similarly, you see no data person attending a front end conferences. Neither front end people are attending database conferences, and because of which there are these silos of knowledge, and we are not learning from each other, right? Like if you attend, like some front end person attended a database conference, they would probably know, like, or maybe you talk to a data person in their team, is they would know that in production sizes matter a lot, and the front end looping you're doing on data, and in production you'll get a million rows. Like how are you going to loop on that in a browser, right? Like don't do that, right? So there's stuff like that you need to like cross pollinate or collaborate or learn across the aisles in some ways.
it's a hard paradigm to break out of, because I'm definitely more of like a I work more with code than like databases, right? Which, I mean, I guess it's all the same. But like I was just constructing a query the other day, and like in my mind, I'm just like, oh, but I'll iterate through through all the results and kind of parse out exactly what I need. I had to be like, no, like just construct the query properly and only return what you actually need, right? Like you were saying, let the database do what it's good at, and then let the code do what it's good at. But if it's one of those things, it's like if all you have is a hammer, everything looks like a nail.
Yeah. And it works both ways, right? People go to the extreme and say, let me generate HTML out of the database and ship back HTML. That's also not good, right? So it works both ways, because then you should use the tool that it was built for. And databases are built for storing data, filtering data, sorting data, and that kind of stuff. Use it for that, and then ship it to the code side that can then decorate it for the end user in much better fashion.
Absolutely.
Separation of concerns comes to mind here.
What emerging technologies? So data's been shifting a lot, at least in my world, where you're seeing really cool patterns like event sourcing, this sort of data mesh patterns that are coming up. So there's a lot more self-serve with the influence of a lot of the decoupling. Obviously, SQL isn't going away; it plays an important role. And then, of course, there's NoSQL databases and a slew of those as well. I would love to hear what you're excited about and what patterns you feel are emerging that maybe are either underfocused or underutilized currently.
Yeah, so maybe I would break that into two parts. One is the architectural style of like consuming data or making use of data and that kind of stuff. And the second part would probably be how do I store data, right? So let's take the how do I store data first. Again, like relationals was big back in like late 90s, early 2000s and that kind of stuff. And then NoSQL came about, and like you mentioned, various types of NoSQL, right? Like there's key value, there's document, there's white column, there's graphs and that kind of stuff. And in the last year or so, you can see the uptick of like similarity kind of databases and that kind of stuff, right? Like especially in combination or in conjunction with LLMs, especially that's been a trend that is coming up. And most of this has been influenced by volume. I have large amounts of volume. I cannot put it in one node anymore. One node is not big enough to handle all that. So I need to distribute data. And when I need to distribute data, there are various ways of doing it, because the relational model is not as favorable for distribution, because foreign keys don't want to go across nodes and that kind of stuff, right? So given that paradigm, there has been a lot of thinking around how do I distribute and what is better ways of distribution and things like that. And the cap theorem played a big role in this. Like, do I care about consistency? Do I care about availability? Or do I care about partition tolerance? Right. So when I give talks, I generally talk about relational databases are like an automatic gear car, right? So you put it in automatic, it makes decisions for you, and it made the decision that consistency is more important, and that's it. Like, you don't have to worry about other things. I don't worry about, like, when I'm using relational databases, I don't worry about, oh, what happens, like eventual consistency, what happens if stuff happens. If I hit a commit, it's guaranteed that data is there. Durability is guaranteed because of asset stuff, right? But when you go to NoSQL, there's a lot more. It's like a manual car gear, like manual geared car, which is like, oh, I'm going up on a hill. Should I be on first or should I be on second gear? Oh, should I like go on three and like do all of these decisions the driver has to take in a NoSQL database? All of the decisions the developer and the data person who are designing these models have to take care, right? And that means, given more levers, you can make all kinds of decisions. Some of it could be wrong, some of it could be right, right? So that's where you need to do a lot more thinking about what is the problem I'm trying to solve and what is the context under which I'm trying to solve. That's where I think Neil and all of us talk about architecture is never right or wrong. It's just correct under that context, right? because given my context, whatever stuff I develop as architecture, it may be right. But somebody else who doesn't have that context looks at that and say, oh my God, what a mess, right? That could totally happen. So that's why building context is super important in the type of problem you're trying to solve. So somebody may say, hey, I'm going to use a document database and I'm going to do all of these things. And somebody else may come and say, with not this context, and say, why the heck did you use documents? This could totally be done with relational. And the answer is, it's not wrong, you're right. But these were my reasons why I used it. So focus on this context is a big stressing point we do all the time, is what is this context? That's why if you look at the software architecture hard parts book, we kind of built a story around every chapter. Like there's literally 2 or 3 people talking to each other. Hey, I want to do this. Have you thought of this? Have you thought of this? So literally it reads like a novel. And the reason is context, right? So context is king. Now going back to the first part of this is like different models. Like before there was the standard like operational database. I want to take it, put it in like a data warehouse for like analytical purposes. So I would probably come up with maybe a dimensional model or maybe something, make it easy for analytics, right? Was kind of standard, right? But now with so much volume and so much different sources of data, then the whole model of I'm going to like analyze a lot, come up with a dimensional model, put data in it, and then query and that kind of stuff. One is slow from concept to cache, the flow of from when I have an idea of some data I want to the time when I get the data so that I can analyze it. That type duration, the concept to cache of that becomes too long in this, and you don't have time for that, right? That's one piece that is driving this. The other piece is schema at read versus schema at write. The dimensional model thinks about schema at write versus the whole like I can put stuff in a data lake and derive data out of that is schema at read. So that's one other way of thinking about that. That's one other trend that is helping this. And the third bit is like the whole driving towards microservices or service-based architectures and that kind of stuff. You no longer have a single database that you can ETL out of and get analytics. There's a order database, there's a customer database, there's a product database. There are like 20 of these around. And you have to think about a different model on how I can get data so that I can analyze this. So there's this, the data mesh concept, what it tried to solve was the order domain may have some analytics that are built into it that can be derived out of the order domain itself. So those are like source aligned data products or source aligned analytics. But there are some analytical questions that span domains, like customer plus order or customer plus product plus order and that kind of stuff. Those are more consumer aligned or aggregate data products. And for that, I need to do certain like shipping of data and that kind of stuff. So then the obvious question becomes is how do I ship data? Like some domains say, oh, once in 30 minutes is fine. Again, context here, maybe not fast moving data and that kind of stuff. So 30 minutes is fine. Somebody may be saying, hey, like I want this like as real time as possible. So people are then like saying, okay, can I use events and that kind of stuff. So the moment you go into events, then how do I save these events? Do I create like persisted aggregated data on the other side, or do I store them as event source? I basically a series of events and I can aggregate them as I need. Those are all questions that come up as you go further down this side. And you can like then decorate this, all of this complexity with the medallion style architecture on the end, the consuming side, where you have bronze layers, gold and silver layers, where incoming data can then be like further processed. So I think the thing that started with this is volume of data, and then all this variety of ways on how people want to get at that volume of data.
You comparing SQL and NoSQL to automatic and manuals is spooky because I just by kind of happenstance have worked in NoSQL for most of my career, pretty much the entirety of my career. Like haven't had to do a ton of SQL work. And also coincidentally at the same time, I've driven a manual car for all those years. And then just recently I got put on a project and a team which is doing a ton of SQL work. And almost like exactly the same time I got moved on that team, my old manual got T-boned and I replaced it with an automatic. And so my my car usage is following my database usage in my career. Well, we're talking about the developments in the tech industry, and we like to ask our authors sometimes just about, the hot thing right now is obviously AI and large language models. What influence do you see those having on working with data or designing database schemas, just kind of the database world? Do you think there's potential there? Do you think it's overhyped? Where do you stand on all that?
I think, again, probably we could think about this in three different ways. One is the influence of large language models on understanding existing legacy schemas, right? Like if you go into organizations, you'll see a lot of schemas, lot of like old databases or like legacy databases that are at the cusp of having to be modernized. They're forced to be modernized because of all the changes and all the new functionality that the business needs. How do we understand those schemas, right? Because there's not enough documentation. It's complex. Like I was looking at a schema maybe about 3 months ago, about 2,000 plus tables, about 7,000 plus stored procedures. How do we understand that, right? Because there is no like metadata about it. There's no column restrictions. People who developed it are no longer around and that kind of stuff. So you can deploy like large language models to like parse this and figure out certain things and maybe give me a semblance of what does this mean, right? So some of that is kind of like where large language models are super helpful. Like ThoughtWorks is working on a product called Code Sense that look at these things and kind of give out information about here are the dependencies, this is how it is structured, here's a graph of all the tables and source procedures and that kind of stuff, which will help you understand, so you can then go to the next iteration of the legacy product into something that is more useful. You can modernize, maybe apply like a straggler fig pattern on these things and that kind of stuff. So that's one area where I think large language models are going to help existing data professionals to understand the legacy systems, right? The second bit where I see this is useful, especially for people who are developing like data products, developing like data pipelines and things like that, they can again use the large language models to understand where they're pulling data from, how they are going to structure, create the metadata, like especially on the data product side, the consuming side, so that people who are consuming your data can easily understand what it means and that kind of stuff. Also, like help you figure out the path from source data to like consuming data side, how I can fasten it up in terms of like applying LLMs to again understand a bunch of these business logic, bunch of like metadata, bunch of like rules, business rules, and that kind of stuff. So that's one other place where I see this helping. And the third bit is using the LLMs themselves to query the data itself, right? Like think of like a chat interface to your data, right? So someone is, instead of saying, hey, I have a dashboard or Tableau or something, or maybe Grafana or something, that I'm going to look at the data and create some dashboards. Instead of that, what if I could ask using chat interface saying, hey, like what were the topmost sold products in the last hour? And LLM would figure out the right SQL to fire or the right API to call. Like think of like agent-based work happening here. And the agent figures out, okay, product sales is in that particular data store or that particular API. I'll go query the API, get the data and show it to the user. And the user can then further ask, can you visualize this? And then it visualizes. Or the user can further ask, can you break this down by region? And it takes that result set, let me break this down by region and tell you what product got sold most and which region contributed to the most sales for this particular product. And then you can go further down, like some kind of interface like that. So you don't have to develop like reports anymore or drill downs or dashboards anymore. You could just like let the user take it on a journey that they are interested in today instead of developing everything up front. So three big spaces I think they will have a huge influence on, and all three spaces are super valuable.
One of the things that I thought was really interesting in the book, Oh, actually, before I get to that, let me take a step back. You were talking about the large language models and querying. It's been helpful. I found I was using an observability dashboard tool. I think it was logs.io or something like that. And they've recently introduced a large language model where you could ask questions of the things that you had set up. And it was very useful when I was navigating unfamiliar sections of the data sets, especially when I needed to ask it questions on like how to help me query the data. It was a great learning tool for me, actually. It was like an interactive onboarding tool. And I imagine that we're just at the beginning of that. I feel like the way that we're going to figure out how to do these, I guess they're calling them RAG, sort of domain specific language models are,
And you
so
can
cool.
think of like each agent serving a particular domain, and it knows that domain very well. And then it knows where the data sits and that kind of stuff. And you could have a bunch of these agents coordinating against each other and deciding, oh, this question relates to that particular domain, so I'm going to use that agent, and then come back with answers for you.
So pitfalls and antipatterns. I think these types of sections of a book are my favorite always, because it's like learning from the failures or learning from easy places to get stuck. Do you have any especially when it comes to like evolving databases, are there any pitfalls or antipatterns that that you think that our listeners should be aware of, or easy that you've seen, with clients and things like this?
Yeah. So I think the pitfalls is more in the type of like process, CI/CD, DevOps, and that kind of stuff. Like people say, I want to do evolutionary stuff, and then don't focus on CI part, don't focus on the DevOps that is necessary, don't focus on like automation and that kind of stuff, right? So for example, like if you want to do evolutionary stuff, then the developer should be able to spin up a database for themselves, put all the schema that's necessary for the developer in that particular database, then put all testing data that's necessary, all seed data that's necessary in that database, and run the app against that database on their own machine or laptop, right? This is a given, like this is the minimum you should have. And then the next bit would be like, oh, once they check in, the same thing should be able to be done by a CI instance, like spin up a database, put my stuff in there, run a bunch of tests, run the app against it, run a bunch of UI tests, do all of that things, right? And then similarly, when you go to the testing side, the testing people don't necessarily want your foo customer, don't necessarily want your like bar product or whatever, because that's what developers come up with. Like foo and bar are standard stuff people put in. They want like good data, right? Then you should have thought about, how am I going to put good data in here? Like maybe use like a fitness function to put stuff in. Maybe you have like Excel spreadsheet where business analysts or product owners give you good data that you then take it in and put it in your database, so that when testers or like product owners or maybe business stakeholders are looking at the app, it has good data, right? So that they can look at it and that kind of stuff. The other bits are about like complexity, and the variety in data matters a lot for test, right? A good example I can do, let's say you're doing a pricing engine. Maybe you make it very specific, like a health policy pricing engine, or maybe a car insurance. Since we are talking cars, let's take car, like a car insurance policy pricing. For that to work, you need to have a good variety of data. You need to have representation of different types of cars, different types of localities that you're in, different types of different states that your customers are in, different types of damages that can happen to a car. That variety is what gives your ML model, or whatever actual model you have, the ability to price properly. If you don't have that, then your models are not going to work right? So how do I get that data in becomes a thing that you need to focus on, and you make it part of the DevOps pipeline. Hey, given all of this data, I have a good way to put this in to my database. And if your database is static, probably you can easily put it in. But now your database is changing too. So you have to have an automated way of putting this data in, right? So that automation becomes critical. So things like this is what people should be working on. Generally, if you don't work on that, then it becomes difficult over a period of time. Like it gets more cumbersome and over a period. So I would say focus on these automation bits. The second part that you should also focus on is what are the conventions, the default conventions everybody would use. Like, for example, again, going back to, let's say we are designing a table. What are the standard stuff every table should have? It should have a primary key. If you are auditing and certain things, you should have audit columns. If you have a foreign key coming in from some table, like I have a customer table and the address ID is a foreign key, for example, like shipping address ID, or like maybe even some other things like that, then okay, those columns, should they be null or not nullable, right? So for example, those kinds of things. Or like the order details table has an order ID, then that order ID cannot be nullable, for example. So you have to have some conventions that incoming is always nullable or incoming is always not nullable. A bunch of these kinds of things you have to set up so that when the developers are doing this, again, a bunch of this is two ways of doing this generally happens. One is you have a database expert kind of a person on the team that is go walking around or sitting on different tables or maybe pairing with different people who are working on the data side and helping them do these things, right? And the second model is you put everything onus on the developer. So they are doing this table design and schema design by themselves. And maybe the review happens on the PR side. Like, oh, I issue a pull request and some person who is good at data is looking at it and then making comments and that kind of stuff. Both models are fine, but for both models to work, you have to have good conventions about certain default things that have to be there, right? Like good naming conventions, good, every table should have these things, every foreign key column should have an index on it, blah, blah, blah kind of stuff should already be all decided by the team. Like you agree on certain things and then you follow those things. And then maybe you can later on, you can apply some linting automation on top of that. Then the lint fails and then you need to fix. So these kinds of scaffolding around this process is super helpful for people to do this. The third bit is the test. Like how do you test all of this stuff? Evolutionary is great until you don't have tests and then evolutionary starts failing everything. And then you're like, oh man, this evolutionary stuff doesn't work. But of course, it works if you have good tests around it. And that testing becomes important. Like, where do I test it from? You can have tests inside the database itself. You can have tests at the persistence layer. You can have tests from outside, like behavior-driven development kind of like JBehave or stuff like that you can apply from outside, like cucumber-style tests. You can apply from outside. So all of those tests becomes critical at that. Yeah. So I see them like all these three pieces helping you deliver in an evolutionary manner.
You talk about the importance of having tests. It's rare you meet a developer who likes writing tests, right? We want to write code and not the tests around the code. What would you recommend to developers who maybe are having trouble building up that discipline to write tests? Because like you say, some of these things like evolutionary architecture, it just won't work unless you got the tests around it.
Yeah. And I would go back to the fear. Like if you have fear of modifying anything, then if you test, the fears go down. Because if something is going to break, it will break on my laptop or my machine, right? If I'm modifying something, again, I go back to this notion of if I want to experiment something and the experiment is isolation to me, right? So I like, hey, I want to put a trigger or I want to drop this table and recreate it or whatever, a number of things could happen. The fear is really high if you don't know what all it affects. And the fear is very low if I can like control that experiment myself. So this is where like having my own instance of the database, having my own test that I can run before I check in, having my own like various ways of testing if this change affected anything else is giving you safety. So that reduces the risk or the fear, right? So if you think you are fearful of change, then probably you don't have enough tests, right? And that could be all kinds of tests, like not just like unit test, it could be integration test, it could be like functional test, it could be like UI test, it could be whatever. All of those are valid. Like at the bare minimum, if I change a table's name, will one of my view creation script fail? Simple, like very simple in the database itself. Then you should have a test that will recreate all the views after you change a table. And it's as simple as compiling all the views again. And one of the compile fails because the table name changed. The view was select star from table name ABC. And you have renamed that table name ABC to XYZ. And now that view doesn't create anymore, right? And that's a test that gives you like less fear because, hey, I can run this. If something got affected, I can fix it and then move on with my life. That's the first level of fear reduction. The second would be, we'll do some stored procedures break because change my table or change my column. Okay, let's compile all these stored procedures again and see if something breaks. And then you keep like this onion keeps on going on top of each other, layers and layers and layers, till you're comfortable, like, hey, I got everything covered here. And I can happily change something and run all of this and nothing breaks, then I didn't affect anything. If something breaks, that's not a bad thing. That is pointing to a place where you need to change certain things because you made an underlying change in a name somewhere. Right? Until the time we get to a point where IDEs can figure out, I change a table name and it'll change everything. That's not a reality yet because there's a dissonance between the code and the database, right? So if I change again a column name, the IDE doesn't know, okay, where all I need to go touch at. If I change a method name, the IDE know within my code scope of my code, it knows where to change. But there's some other code base which is probably calling your API. We don't know, right? So for that, we have tests. Just like how we have API level tests to guard against API changes, you have same kind of tests to guard against database changes.
Are there any unconventional fitness functions that you like in your like bag of tricks, like when you're talking to teams and you're like, here's a blind spot or an area that you haven't been paying attention to?
Yeah, most of the like places where that happens is when you make certain changes and stuff starts failing, right? And many a times you see this, like ideally you want everyone to use APIs to your database, but invariably it happens that people, hey, I have like this data I want to pump into the database, let me write directly to the table. Or there are these other people who like, I want some extract out of the database, so let me pull directly from your database without talking to anyone. This invariably tends to happen, especially if your code base is 4 or 5 years old and it's sitting in production for a long time. And then people start doing stuff with it. You have no idea who's doing what, right? So at that point of time, like knowing who does what becomes critical, right? And then taking that as a fitness function on your own code base. Hey, there's this script that is pulling data from my database. Instead of stopping them, or of course, stopping them is not the idea, but convincing them to use some other method may be a good way. But if you cannot do that, then writing a fitness function that says, hey, like make sure you cover that use case in a function somewhere is helpful, right? At the same time, like many a times, again, most of the use cases that I'll talk about come back to the legacy side of this. In the legacy side, like execution paths, like I call something and that in turn calls something. If you have stored procedures, becomes really cumbersome to understand. Like how do I test that? How do I ensure that I have this whole execution graph covered? Becomes a big deal. So those kinds of things, like write a test for it and run something, figure out what went wrong, and then write a test for that too, and then keep going, is a thing that we have seen a lot of, right? So that I think those two things are really critical, especially if you're dealing with legacy art. If it's a greenfield project, then this I don't have time to write tests. Like what Carter was mentioning about, I don't have time to write tests, and because there is so much stuff to do, I would at least ensure that you make it mandatory that you would at least write one test that will persist something and retrieve the same object back, minimum, right? So if I have a customer object, at the persistence layer of the application, I'll say create a customer, give it all the necessary stuff, and then get it back. like find customer and save customer. There could be other instances of delete a customer, modify customer, maybe a little bit more advanced, but at the minimum you want to like save and retrieve. And that will cover like hitting the table, hitting all the columns, reading back from the table, reading all the columns and that kind of stuff. So that you can, like if tomorrow you modify certain things, these tests will protect you against inadvertent changes. Minimum you want to do that. And for a developer sitting in a code base, writing like some save function and retrieve function is much easier than like, oh, let me write a side fitness function somewhere that is using some other framework to save a customer and retrieve.
Great.
That all makes sense. Yeah, it's I like what I like that final recommendation you have of like at the very least do this, and I like what you're talking about, how just all the different points it hits, because that sounds like a really simple test, right?
Yeah.
But like you said, you're testing the database connection, you're testing persistence, you're testing the models, and the schemas. Like it's yeah, I that's a good bang for your buck kind of mentality, and like obviously we all want to be as thorough as possible with our tests, but I do think that there is sometimes this feeling of like, if I can't do my tests perfectly, then we should just not write them. And that's not true.
That's not true. Yes.
Well, we always like to ask our authors towards the end of the interview. Obviously, this podcast is focused on books, and we read a lot of books here. So we always like to ask our authors if there's anything you've been reading or anything you would recommend to our listeners. And we'll take anything, right? We've had sci-fi recommended, a cookbook, we've had legal books recommended. Anything you would recommend to any of our listeners?
Yeah, maybe in two categories. One in the data side, like there's a lot of like, as you know, a lot of different styles of analytical architectures that are coming in. Like there's data mesh, there's like lakehouses, there's like data fabrics and all that kind of stuff. So there's a book called Deciphering Data Architectures. That's pretty nice. That if you want to understand like a broad swath of like different styles of architecture and that kind of stuff, a good book to read and figure out what kind of things are happening. The other area that I generally read a lot of books is in the economics side of the shop here. So recently I read like applying computer algorithms to life. I'll send you a link to that book later on. But it talks about like, oh, what's the optimal stopping algorithm? How can I apply it to my life? Like, or think about like other types of algorithms that you have dealt in computer science, how you could apply them in your life, like day to day human things and that kind of stuff. There's also a book called Thinking Fast and Slow, Daniel Kahneman, a really amazing book that I have read a lot, like maybe read multiple times, trying to got the idea of like, okay, when should I stop myself on saying something, sit back, think, and that kind of stuff, and why the mind thinks in certain ways and that kind of stuff. That's been a really good read. I am also reading, like right now, I'm reading a book called the six personality types in any organization. Not yet finished with that, but that talks about like there are in an organization there are people like who are really on the innovation, want to innovate all that time, and like if you give them like production fixing work, they get bored. Versus there are some people who like to fix production problems, fix like bugs and that kind of stuff. But if you tell them to be on the innovation team, they get bored or they don't like it. So there are six like distinct personality types in this. Like, how do you recognize them? How do you put them in the right teams? How do you work with them and that kind of stuff? Really interesting way of like figuring out how you want to like structure your teams, behave, like interact with team members and that kind of stuff. So yeah, that's been a good book. Still not finished, but it has good pieces too.
That's great. We're big advocates for understanding the whole when it comes to software development, and a big part of the whole that I think is too often neglected by engineers is the people part.
Yeah.
Let's say all software is built by people, and so you can't understand software without understanding people. Right. So we love hearing about those sorts of books like that. Well, Pramod, thank you so much for stopping by. It's really a pleasure. We joke about us completing our infinity gauntlet of Building Evolutionary Architectures authors, because we have Neil Ford, Rebecca Parsons, and now we have you. We just got to get Pat Qua on, and then we'll have we'll have done everyone. Well, you can always just for our listeners, the book is Building Evolutionary Architectures, again by Neil Ford, Pramod Sadalage, Pat Qua, and Dr. Rebecca Parsons. We'll have a link in the bio, and we did a few episodes on it. You're welcome to check those out. You can keep up with us at Book Overflow Pod on Twitter or X or whatever you call it these days. You can find our website at www.bookoverflow.io. That's where you can find our book schedule and links to all of our different platforms. You can find Nathan's work with Functionally Imperative, his newsletter, and interview series at www.functionallyimperative.com. And you can find me on Twitter at Carter Morgan. Pramod, are you on Twitter or any sort of platforms that you'd like to plug here?
Yeah, I am slowly trying to get out of Twitter, but I still have a handle there called Pramod Sadalage. And I am usually more active on LinkedIn, just trying to see what other people are up at. You cannot find me on Facebook or Instagram.
We haven't had any author plug their Instagram yet, but I'm waiting for the day. Well, again, Pramod, thank you so much for stopping by. Really a pleasure to interview you. And listeners, you can catch us next time with either a discussion episode or another interview with authors when they're kind enough to stop by, like Pramod was today. See you around,
Thank
everyone.
you. Yeah. Thank you, Nathan and Carter. It was a fun conversation.
Absolutely.
Yeah.
No, thank you.
All right.